Hello, my name is Brenton Kidd. I am a junior at UCO, and today I want to talk about the circulation of the Earth's atmosphere and how that affects society and Earth's weather patterns. The general direction of the wind varies around the globe depending on factors like altitude and proximity to oceans. The direction of the wind at various levels in the atmosphere determines the local climate and steers around weather systems and other types of severe weather. Pressure varies, however, from day to day at the Earth's surface, the bottom of the atmosphere. This is in part because the Earth is not equally heated by the sun. Air Areas where air is warmed often have low pressure because of the warm air rises and are called low pressure systems. Places where air pressure is high are called high pressure system. And I will discuss both of these types of different pressure systems in the next two slides and give more in-depth detail. A lower pressure system has lower pressure at its center than the areas around it. Winds blow towards the low pressure, and the air rises into the atmosphere where they meet. As you can see in the picture here, where the red lines are, that's where the air is rotating and moving counterclockwise and lower levels, and the air is moving in an upwards position. As the air rises, the water vapor within condenses, forming clouds and often precipitation too. Because of the Earth's spin and the Coriolis effect, winds of a low pressure system swirl counterclockwise north of the equator and clockwise south of the equator. So the image you're seeing here of the low pressure system is in the northern hemisphere. And reasons for this is called the cyclonic flow. And most times on weather maps, a low pressure system is labeled with a red L to indicate the low pressure systems. A high pressure system has higher pressure at its center than the areas around it. Wind blows away from high pressure. Winds of a high pressure system swirl in the opposite direction as a low pressure system. Clockwise north of the equator and counterclockwise south of the equator. This is called anticyclonic flow. Air from higher in the atmosphere sinks down to fill the space left as the air blows outward. On a weather map, the location of a high pressure system is often labeled, well, not often, most is labeled with a blue H. And as you can see here in the graph here, the anticyclone flow is moving downward and creating a high pressure, which causes diverging air instead of converging air, as in the left side, which would indicate a low pressure zone. The Coriolis effect can be seen in action in the general circulation of the Earth's atmosphere. The winds at all altitudes to the north of zero deflect to the right of the intended path in the northern hemisphere. The Coriolis effect does not impact the wind speed, only the wind direction, as you can see in the graph, in the picture on the slide, and how this affects the air around the equator. And the Coriolis effect impacts objects on a large scale and does not generally have a big influence on a small scale objects at the Earth's surface. Though hurricanes are small scale compared to the overall globe, hurricanes need the Coriolis effect to help develop the kinds of circular motion of their cyclones and things and how they rotate. However, tornadoes are not impacted by the Coriolis effect because they are so small in scale and short in duration. The direction water goes down the drain is also not impacted by the Coriolis effect. It's more of just having to do with a lot with ocean currents and just the overall direction of wind through these patterns, and it does very much have an effect on low and high pressure systems.